Hi, this is the first video in a series for the third taller in the Innovation TIC module of Gestión Estratégica del Proyecto de Arquitectura. The idea with this video is to think about the upcoming workshop and take a quick look at how the data that we're going to work with was generated and the format that the data is stored in. So I'm just going to run through the various stages that we use to create the data set. The first stage starts with the extraction of spaces from a Revit model provided by Los Andes Facilities Management. That model unfortunately did not have any spaces or rooms defined in it, so required a bit of manual modeling to define basically a floor boundary for every single space. Those boundaries were taken into a Rhino model, and then for each space type they were located on a separate layer. So you can see the layers here: classrooms, corridors, meeting rooms, cellular offices, open offices, bathrooms, and a set of floor points that represent the floor levels for each of the levels in the building. Once those layers are assigned, I then switch over to Grasshopper, where we define the names of those layers and make a reference to this particular model. This component here is just extracting the geometry that it finds on each of these layers. So I know that these groups of geometry, each of them is a particular space type, and the other input here is this is the area per person in each of these space types, so we can ultimately calculate maximum occupancy. And then here we have the name of the output file that we're eventually going to write to, and here we're referencing the 7 floor levels, which we're using just the Z value to define the exact height of each of the spaces. And so what I've got here is a little custom component written in Python, and if we double click on this, we can take a look at the code. And the main part of the code is down towards the bottom here. First of all, we define a start time. You can see here 2019 April the 1st, 9 AM, end time same day at 1 o'clock. So this is a small data set. I then am pulling a subset of a year's weather data, and this is coming from an EPW file, which is just a simple text file, and you will have access to this. Let's just take a quick look at that simple text file. Here's the climate data. So basically what we have, starting here on line 9, we have a year, a month, a day, an hour, and then a set of data that each of the fields relates to some kind of climate data measurement. So that first part of the code there, we're looking at that weather file and then just generating a subset based on the start and end dates, just so we can quickly find relevant weather. And then once we've got our weather, we're then going to step through each space type, so basically the geometry that's on each layer, and then within each space type there is individual spaces. So we step through basically a rectangle or a closed curve, and for each of those closed curves we are defining a specific floor level, getting the points for the boundary of the space, checking that the boundary is planar, and then computing the area of that boundary. You can see that in the code here. So we're stepping through here each of the space types. This is the name of the space type, and then the area per person of that space type, and then for each of the curves within that space type, so each of the curves within that level, we define the floor level, we get the points of the curve, we make sure those points are flat, that the curve is flat, that they all share the same Z height, and then here we're just computing the area using this area mass properties object, and then last of all we can create a space object. So we create the space object, and then once we've got the space object, we can call generate the sensor data, and then this moves us into a function within the object that increments by 15 minutes from the start time to the end time. We can take a look at the quick look at the code for that. So here we are in an external Python module that we're using within Grasshopper. So generate the census data, so we need the start time, the end time, the weather data. We have a while loop here, which is simply incrementing 15 minutes every time we pass through the loop. We first of all get the specific closest weather data record for that particular time, and then calculate a range of sensor information, most of which is based on something called the occupancy factor, which is determining how busy a room would be depending on the time and date. And based on that, we can calculate what the number of people in the room based on the max occupancy and the occupancy factor. And then following on from that, we can determine whether lights are switched on and off, whether windows are open or closed, whether projectors are on or off. We define temperature reading based on the outside temperature, the number of people, and the maximum occupancy. Similarly with relative humidity, CO2, and then the airflow is dependent on the people in the room, max occupancy, and whether windows are open or closed. N here is the noise, so we set that based again on a base level and the number of people. And finally, we can create a single sensor record and add it to an array of sensor records that's stored in the space object. And we repeat that process every 15 minutes. So get the sensor values, create the object every 15 minutes until we reach the end time. Once we reach the end time, we go back to move to the next space and repeat the whole process again. Once we reach the last space on the layer or the space type, we then move to the next space type before finally writing the text to a JSON format.